All right, so we're going to talk about precipitation reactions in this slideshow. Our objectives: we will define what a precipitation reaction is, we will learn about solubility rules, and then we will apply the solubility rules to various examples. We classify types of reactions. When you mix two solutions and get a solid, we call it a precipitation reaction. And it leads to the terrible chemistry joke: if you're not part of the solution, you're part of the precipitate. Ba-dum-bum, ching. Anyway, on the right, we have a precipitate that is formed when adding HCl, hydrochloric acid, to silver nitrate. It forms silver chloride, which is white and looks like a cloud in the test tube. Precipitates often look cloudy when they form, and they settle to the bottom of the solution, as solids are generally denser than liquids. For all precipitation reactions, the cations will swap the anions. So in this case, you had HCl and you had AgNO3, and so we made AgCl by swapping the anion. Finally, it turns out that not all ionic compounds dissolve in water, so we're going to need to get an intuition about what will and won't dissolve. We'll learn solubility rules to summarize the experience of many centuries of combining two solutions to make or not make solids. Okay, so I have this labeled solubility rules, soluble, so that we should define soluble. Soluble means that something will dissolve in water, and insoluble means that it won't dissolve in water. We have a few caveats for when we get into solubility rules. These rules, and I use that loosely, apply to things at room temperature. So if it's not at room temperature, this won't apply. Some things we declare insoluble will become soluble if we heat them up. Additionally, these rules are imperfect generalizations. And finally, different books do different rules. So I'm using the ones from this book in the next two slides, and then something else in the next one. Anyway, I'm going to split the rules up into soluble and insoluble, and I'm giving the tables different colors to try to create a different association in your head. In this case, soluble will be blue and insoluble will be orange. We'll see if it helps with the memorizing. Anyway, all group 1 cations are soluble in all situations at room temperature. So that's lithium, sodium, potassium, rubidium, cesium, francium, The mid-range halogens, chlorine, bromine, iodine, are soluble, except when combined with silver, mercury, and lead. Now, you may be wondering, why have I written Hg sub 2+ for mercury? Mercury as an ion forms a dimer, meaning two atoms together. So that is actually the form that it takes as an ion. It is always found in that form. Some lists will just say mercury, but what they mean is Hg2+. Fluorine is soluble unless combined with group 2 cations, lead 2+, and iron 3+. Acetate, C2H3O2-, bicarbonate, nitrate, and chlorate are always soluble. And finally, sulfate is soluble except with calcium, strontium, and barium from group 2, as well as silver, mercury, and lead. And just for the record, calcium, strontium, and barium, they're all in a line in group 2, which makes it easier to find them. There are various ways to remember these, and I am going to direct you to the YouTubes to look up mnemonics for the solubility rules, because I will be honest, I suck at them. I just know it from familiarity. I did not memorize this ever. All right, solubility rules, the insoluble things. These things will be insoluble except when they're mixed with other stuff that makes it soluble. Anyway, carbonate, chromate, phosphate, and sulfur are insoluble unless mixed with group 1 cations or ammonium ion. Hydroxides are insoluble unless mixed with group 1 cations or barium. This is a summary table that also includes things that are slightly soluble, which in the other version are marked insoluble. You can pick the version that you like, that you find it easiest to work with, and go from there. We'll discuss later what we put on your reference sheets. All right, so let's try to apply the solubility rules. We're going to write an ionic equation and then a net ionic equation if we form a precipitate. So if everything is soluble, we say no reaction. Let's try lead acetate and sodium chloride. So we're going to go on our chart here. We're going to find lead, and then we're going to find the crosshairs with chlorine, because remember we're flipping our anions. And we end up in the insoluble box. So this is insoluble, which means we do have a reaction. If we have two things that form soluble things, we say that there's no reaction. So let's write the ionic equation. Or rather, let's write just the balanced chemical equation. So we have lead 2 mixing with sodium chloride. We make lead chloride and sodium acetate. Now, our solid is forming from lead and chlorine, so our net ionic equation is just going to include those anions. And there we have it. Lead 2 plus 2 chlorine makes lead chloride solid. So at this point, I want you to try to apply these solubility rules. Take pause here on this slide. Write a net ionic equation if the two form a solid, and if not, write no reaction. So go ahead and do these 3 examples, and then the next slide will have the answers. Right, so sodium sulfate and calcium chloride will give you an insoluble salt of calcium sulfate. Lithium hydroxide and iron nitrate will give you an insoluble salt of iron hydroxide. And sodium nitrate and sulfuric acid do absolutely nothing. Everything is soluble there. Everything's a spectator, so there's no way to write a net ionic equation. So to summarize, when 2 solutions form a solid, it is called a precipitation reaction. If the materials are soluble, we split them into ions, and if they are insoluble, we label them as a solid. Follow the solubility rules to predict when you have a precipitation reaction take place. All right, so hopefully all of that made sense, and it won't be too hard to apply, but there's some stuff that you're going to have to constantly look up for a while.